and plane B is flying west. Okay, that's a little different setup. All right, so we got two planes, A and B. And at our reference point here, it says they are 100 miles. A is north of B, so A is 100 miles like that. But what about A? Which way is it going? It's going east. B is going west. So let's call this distance here X and this distance Y. Yeah. The A is going a little bit faster, so let's make it a little longer there. Okay. How fast is the distance at a constant altitude? All right, if we change in altitudes, that would throw a monkey wrench in there. But these are staying at the same altitude. How fast is the distance changing between them after 45 minutes? So what am I looking for? I'm looking at this distance right there, which is our Z. How fast is that changing? So again, I'm looking for dz dt. And again, I have dx dt. What's dx dt? The rate at which x is changing? It's 100 miles per hour. What about dy dt? It's 80. So I know about the same thing. And then this time, it's 45 minutes, but that in hours would be, take 45 divided by 60 hours, so that's 0.75 hours. So my time is 0.75 hours. So I've got basically the same information, however, we have a lot different picture, don't we? What do you see there? Well, if we leave it as is, I see two right triangles. But I don't want to leave it as is. What if I did this? What if I brought this little distance down here and then drew that right there and just focused in on this triangle here? So this long side here, and then this, this. What do you know about that? What is this right here, this long side? What would that be? Wouldn't that be Z? Right? What would this be? This vertical side right here. Well, that vertical side, doesn't that amount to this side that's 100? That's 100. Huh? Oh, 50 miles? Where'd I get 100? I wrote 100. I don't know where I got 100. Yeah, I mixed up the hundreds and the 50. Okay, I'm sorry. Yeah, that should be 50 right there. Thank you. All right, that would be 50. Now what about this one? Well, this one, you see, amounts to this, which is y, and this, which is x. So isn't this distance here x plus y? All one right triangle. Instead of leaving it as two, just translate those a little bit, and we get this right triangle right here. So what is our equation then? It's just a little Pythagorean theorem, right? A squared plus b squared equals c squared. Well, let's say this is the A, this is the B, and this is the C, right? So x plus y squared plus 50 squared, b squared, equals c squared, which is z squared. Everybody okay on that equation? X plus y squared plus 50 squared equals z squared. So step 1, draw the picture. Step 2, label. Step 3, equation. What's step 4? What do I do with that now? Take the derivative with respect to t, right? Because I'm looking for dz dt. So I want to ddt this equation here, both sides. Take the derivative with respect to t. All right, so what about for x squared plus y squared? How do I do the derivative of that? Chain rule? Chain rule, okay. So the derivative, so bring down the power. The inside stays the same. Subtract 1 from the power, then multiply by the derivative of the inside. What's the derivative? And it's an adding, so what's the derivative of the first guy? Derivative of x. Well, just be 1, but I'm doing the derivative with respect to t of an x, so that's 1 dx dt. Then the derivative of the y part of the inside, well, that's 1 dy dt. With me okay on that? Now here's the good news. What's the ddt of the 50 squared? Well, it's a constant. What's the derivative of a constant? 0. So let's just leave that off. And then that would be 2, the derivative of the right would be 2z dz dt. And I do like to cancel those 2's out. You don't have to, but I like to. All right, so the x plus y, clean this up a little bit, x plus y times dx dt plus dy dt equals dz dt. Z dz dt. Hope I said that right first time. All right, so we ddt'd it. Now what? Now we go back and do a little substituting. X and y being these distances, x is how far the A plane travels. Well, x, the rate of x, that plane, its rate was, that was the 100. And the time, well, the time we said is 0.75 hours, so 100 times 0.75, that's going to be 75, isn't it? The y is how fast the B plane travels. Well, it's going 80. Yeah, 80. And it's traveling also 0.75 hours. So 80, is that 60? 80 times 0.75? All right, so x, we've got 75, plus y, we got 60, times dx dt, well, that's how fast x is traveling, that's 100. dy dt, that's how fast the y1's traveling, that's 80. What about z? Well, z, I've got to go back and plug them in and get the right triangle again. I didn't leave myself enough space there. Oh, well, okay. All right, so x to get z, x plus y, that would be 135. See if I can draw one right here real quick. So that'd be 135, and that's 50. And so that's z, so it'd be what? 135 squared plus 50 squared equals z squared. And so that would be 135 squared, 18,225 plus 50 squared. Altogether, this is 20,750 is z squared, so square root of that is z. That's what I get. Anybody else get that? Does that sound about right? Believe that? So z is the square root of 20,750. So this is going to be 135 times 180 equals the square root of 20,750 dz dt. 135 times 180 is 24,300. Then I divide that by the square root of 20,750. And that's dz dt. So what is dz dt? I get it to be 168.69. 168.7. And that's miles per hour. Is everybody okay with that? Did I do that right? Did I have another miscalculation somewhere? Okay. How many more have we got? 2? Got 8, I think. All right, number 7. Number 7, we change a little bit. A trough is 10 feet long and its ends are shapes of isosceles triangles, which are 30 inches across at the top and 18 inches high. If the trough is filled with water at a rate of 15 cubic feet per minute, how fast is the water level rising when the water is 1 foot deep? That's a mouthful. Okay, so here's the trough. Something like this. All right, so what we know is, let me draw this cross section here. We got an isosceles triangle. Isosceles just means it's 2 sides the same, so these sides are the same right here. And it's 30 inches across at the top, and it's 18 inches high. How fast is the water level rising when the water is 1 foot deep? Okay, so I've got it, let's draw in a little water line there. So the water line's coming right about there. So you can see what's changing as the water level goes up and up and up. Well, the volume's changing. You're getting a longer base here. And so, yeah, your volume is changing. You get more and more water in there. So things are changing. Okay, so what do we want to do? Well, what we want to do, oh yeah, and this is 10 feet here. What are we going to do with that? Well, here's what we're going to try to. The thing of it is, this well, let's just label this rate. That's how fast the volume's changing. So that's dV dt. How fast is the water level rising when the water is 1 foot deep?
Then I said.
Okay, well, here's the thing. You've got your height of your water, and that's what we're focusing in on. We want to know how fast that's changing, the rate of change of that height. So aren't we looking for dH dt? When h is 1 foot deep. All right, but notice here we also have another variable. It's the base. Call this b. The base of your, because if you look at it, the triangle there, thinking about that height, the base would be that, so let's call it b. So we have that little feature. What shall we do? Well, we need an equation. Does anybody know an equation for this such a shape? Yeah, it's not going to be in the front. Sorry. But when you have this shape, do you notice here I've got this cross-sectional area? When you have a shape like that, if you take the cross-sectional area, the volume is going to be the cross-sectional area of that triangle times the length. Yeah, when you have a shape that goes, goes the same through the whole shape, if you find out this cross-sectional area and multiply it by your length, that'll always give you the volume of that thing. Okay. All right, well, in this case, the cross-section is a triangle. So what do you know about the area of a triangle? 1/2 base times height? And then the length, well, the good thing about the length, and we mentioned this, well, I haven't mentioned to you in a lecture, but the good thing about the length is the length varying? As you go up and up and up with the water level, isn't the length staying the same? I can substitute that in because the length is constant. You don't want to substitute values unless you've got a constant. And the length is going to be constant no matter what height of the level you're at, water level you're at. Now, I'm wanting h as 1 foot, but can I substitute that in yet? No, because the height is what's varying, and so I don't want to substitute the height here. Okay, so cleaning that up a little bit, I can substitute the 10, but I'm not going to substitute the 1 because it's varying. I'm just taking the h to be 1, but I can have the h. Well, the h could vary up to well, it could be, that's it, 1.5 feet. So it could go up between 0 to 1.5 feet. So anyway, clean this up. 1/2. I can cancel the 2 into the 10, so that's going to be 5. So volume is 5BH. Okay, cutting to the chase here. One problem I have with this is I can't ddt because I'm trying to find dH/dt. I can't ddt yet because, do I know anything about dB/dt? No. I can't ddt yet because I've got B and I've got H. Now dV/dt, I know something about it, so I'm okay on that. But if I ddt this, do you see I'm going to have a dB/dt term and I'm also going to have a dH/dt term. That's not good because I don't know, do I have anything up here that says anything about dB/dt? No, I don't. So what I need to do is get B in terms of H, if I can. In other words, take this down to an H equation only. First of all, before I ddt. Here's how I do that. Do you see here, if you look at the big triangle and then this little triangle, with this is H and this is B, do you see I have a nice little scenario here? What do I have? Similar triangles, aren't they? And what do you know about similar triangles? Their sides are in proportion, right? So I can set up a little proportion. Now, one thing to note is, I don't think it would matter a whole lot, but since my length's in feet, I need these in feet, so let's change these to feet. What would 30 inches be in feet? 30 divided by 12 is 2.5, isn't it? And 18 is 1.5 feet. So I've got a relationship here. This side here, which is 2.5, is to be as this, which is 18 inches or 1.5, is to H. Can I say that about similar things? Yeah, their sides are in proportion. So 2.5 to B is as 1.5 is to H, or equals 1.5 H. Okay, well, if I cross multiply here, I get 2.5 H, this times this, equals 1.5 B. And so what is B in terms of H? Well, divide by 1.5 here. Whoops, where did I get that? I just divided by 1.5. So 2.5 divided by 1.5. How does that reduce? If you move that over, it's 25 over 15 H, which is, that reduces by 5, doesn't it? 5/3 H. Okay? So there you go. There is B in terms of H. Now, why did I get that? Well, now I can take that little thing right there and I can substitute it for B right here. So the volume is 5 times, instead of B, I'm going to put in 5/3 H times H. Placing 5/3 H for the B. Okay, well, that gives me 5 times 5/3 is 25/3. H times H is H squared. Now I can ddt. Now ddt both sides. Take the derivative with respect to t. The derivative with respect to t of that would be 1 dv dt, or just dv dt. The derivative of that with respect to t would be 25/3. ddt that would be 2h dh dt. dv dt. Well, I know that was given, wasn't it? The change in the volume. Change in the volume, it tells me, is 15 cubic meters per minute. So I'll put a 15 in for dv dt. Equals 25/3 times 2. Now the height I want, now I substitute the height, which said, well, height was 1. So h is 1. dh dt is what I'm looking for. So I get 15 equals, let's see, 25/3 times 2 times 1, I think that's 50/3 times dh dt. Nice way to solve for dh dt there is multiply by 3/50, both sides. And that'll get me 45/50 equals, the 50s cancel, the 3's cancel, dh dt. And 45/50, if you reduce that by 5, that'll be 9/10 dh dt equals dh dt. And the units, well, the units would be the height units, which are feet, over time units, which are minutes. Yeah, minutes. So it's 9/10 feet per